In this video, I'd like to take a look at the second part of section 7.6, where we are studying quadratic functions in the vertex form. You will recall from our first part that our goal in this particular lesson was to identify and graph quadratic functions in the vertex form. We want to make sure that when we give it to you in the form we call the vertex form, that you can indeed, first of all, tell that it is a quadratic and then draw a quick sketch. Now, one of the questions we've not yet had a chance to try is a question which is very common where I give you the graph and I ask you to write the equation. So, when we look at this and consider how we work with the vertex form, the vertex itself is pretty important in the equation. And so, identifying where that vertex is, I realize it's at -3 and 4. And so, I can now take that vertex and put it into the equation. The -3 goes in with the x and the sign changes, and the 4 is placed at the end of the equation. Now, looking at what you have, you're doing pretty well, but you still need to calculate what the a value is for this particular equation. And so, in order to be able to do that, we're going to need at least one other place where the graph crosses through a point that we can identify. There's one that's easy to see right here. It's the -1, 2 point. And you see what that's telling you is that when x in this function is a -1, then y is a 2. So what I do then is take those values and I plug them in. I say y is a 2 and I put x as a -1. And if you just look through the equation now, you should be able to tell that you have only one variable left to calculate. So you should be able to do it. With a little bit of work, you'll be able to figure out what a actually is. So first, we need to think about the order of operations. I need to take care of what is inside of the brackets. -1 plus 3 is 2. Then I'm going to need to use or calculate the exponent, and 2 squared is 4. Now I'm ready to try to isolate a, so I move the 4 to the other side. That gives me -2 is equal to 4a. And lastly, I will divide both sides by 4, giving me -2 over 4 for my value of a. I'm going to reduce that, so it's -1 over 2. So now I know what the a value is, and I can take the a value and put it into my equation to give the final equation of the graph. Y is equal to -1/2 onto x plus 3 squared plus 4. Now, a couple of questions for you that I want you to be thinking about as you imagine what a parabola looks like. The question, first of all, will all parabolas have x-intercepts? If you stop and think about the way parabolas are shaped and what they look like, hopefully you can consider that there are a couple of cases where we will not have x-intercepts. One is up on the left, where we have a vertex above the x-axis and the graph opens up. It'll never touch the x-axis. Down on the right-hand side, you see there's a vertex down below the x-axis. And because the graph is opening down, we will not have any x-intercepts. So the answer to that question is the graph will not always have x-intercepts. It can, but it will not always have them. Next question, will all parabolas have a y-intercept? If you consider what the parabola does as it opens up wider and wider and wider indefinitely or infinitely, then yes, it will always cross the y-intercept. Now let's take a look at the question we started the lesson with, where we had a dolphin jumping in the air, and we could tell by the shape of the curve that he was going to follow this beautiful parabola. You'll remember that I asked you what would you need to know to be able to create a quadratic function that describes this dolphin jumping in the air. Well, if I were to give you the following graph, hopefully that would give you some clues about what it is you need in order to be able to give me the equation. First of all, you're going to need to identify where his vertex is. The vertex is at 3 and 7. And we're going to take those numbers and put them into our quadratic equation function. And so we put in the 3, make sure it's a negative, and the 7 on the end. So first we identify where our vertex is, and you can see that it is located at 3 and 7. So we'll put that into our equation. And notice that the 3 becomes a negative. Next thing we need to identify is one other place that the graph is crossed clearly through some kind of spot. And in this one, it's passed through the point 9, 4. So now I know that when this graph passes through there, that the x is equal to a 9 and the y is equal to a 4. So I'm going to put those numbers into my equation and then go ahead and solve it. 9 minus 3 is 6. 6 squared is 36. Trying to isolate the a, I'll move the 7, so I have -3, and then I need to divide by 36. When I reduce that, it's -1/12, and that gives me everything I need. All of the pieces are ready, and I put it together, and now I know what the quadratic function would be for this dolphin's jump. Okay, that finishes the types of questions that I wanted to go over with you for this particular section. We were seeking to identify and graph quadratic functions in the vertex form. And I gave you the following homework, which was just 2 questions where I wanted you to practice some of the things that we've been working on in this part 2 of section 7.6. So good luck with your work, everyone.